Let's go. Sydney wants to predict how much energy she'll have. She displays all of them correctly, which then displays the data best. Graph A. Graph D is solid. Temperature is degrees Celsius. Doctor studying nutrition. Collects data in height. Children in America. The table below shows the mean heights for children, different ages. 5, 6, 8, 10, 12. 5. 1.1. 6. 1.2. 8. 1.3. 10. 10. 1.4. 12. 1.5. Which of these best describes the linear model? So it has negative slope. The slope is, this is also 1, so it goes down 3 hours. It has a slope of 10, 3, so that's 3.3. It's close to 3. 4 is close to 3. Plus 42. That makes a lot of sense to me. Let's go down. If we go down 20, that's 5.5. That's 20 over 5.5, which is just about 4. I'm happy with that. Based on the equation, estimates the number of complaints, where the average is 3.5. So 3.5 times 4 is 12, 14. So that's 42 minus 14, 40 minus 12, 30 minus 2, 28. Based on data which the following statements must be true about the people surveyed. Okay. Person's role model and their highest level of education. So based on the data, which the following equations must be true in people surveyed. Must be true. The person who has the highest level of education is less than high school. Is more likely to have a stranger than a friend or acquaintance as a role model. Yeah, that seems right. Let's look at the other options. So bachelor's degree, then family member versus stranger. Must be true. It's this. We only know the column frequencies, yeah. Felt strange to just have a D and C. Two ratios. So is it percentages? So we know that this equals 100. So what's it? 97 plus 28. It's 125. So I have 28 divided by 125. We get right to the nearest hundredth. So 0.22. And we have 97 divided by 125. We get 0.78. Let's do the same with the sports score. 35 plus 104. 35 divided by 104. 35 plus 104. And we have 35 divided by 139, which is 25. 0.25. This means this must be 0.75. Double check 104 divided by 139. 75. It should be right. The graph shows the relationship between population density and average rent for one-bedroom apartments in different cities. What statement best describes the association between these two variables? We have this general positive linear association. Let's turn a trend up. This lowest is not found. This is a new lowest. This is a new lowest. This is a new lowest. That's a new lowest. And keep on reaching new highs. So cities with higher population density tend to have higher rents. There seems to be not much of an association. So positive would be like this. A negative association would be like this. Nonlinear. That might be nonlinear. Might be a nonlinear association. What if it's a nonlinear association? Maybe it would be no. But wouldn't that just mean it's parabolic? I think it would be. Or exponential. And not linear association. Julio described a survey to his fellow students asking them how many hours they spend playing sports in the past day. He also asked them to rate their mood on a scale of 0 to 10, with 10 being the happiest. Julio created the scatter plot regression line to show this relationship. The fitted line has a y-intercept of 5. Okay. So you have hours playing sports. So this is mood, this is hours playing sports. So with 0 hours playing sports, the average rating was 5. Researchers surveyed recent graduates at 2 different universities about their income. The following two-way table describes data for the sample of graduates who responded to the survey. Other graduates in the sample, what fraction came from University A? The total, so we're going to look at 160 over 300. Just see. Yeah, they're just recent graduates. Nothing has to do with money. We're just looking at A versus B. So 160 divided by 300, that makes sense. Researchers had once studied on which superpower would they most likely to have. How many females respond to the survey? So we have 1, 2, so we have 40 plus 12, that's 52, so decks of cards. Deck of cards is 52. Yay. Leah knows the information. So Leah knows the information about the 50 days where she tracked where she wore a tie or whether she received a compliment on the outfit. There were 11 days of which she did not wear a tie. There were 11 days of which she wore neither a tie nor received a compliment, and there were 30 days in total where she received a compliment. Can you help Leah organize the results in a two-way frequency table? Let's see. So she has 11 days. The sum is 30. 16 days where she did not wear a tie. 16 days. And there were a total of 50 days. So we have 30 minus 16, which is 14. And she did not receive a compliment. 50 days, so we're going to have 14, the sum of 14, 16, and 11, 15 minus the answer. So 19 days. So there's 11 days where she wore neither a tie nor received a compliment. That's correct. There are 30 days in total where she received a compliment. Correct. There's 16 toes where she did not wear a tie. Oh, in total. Ooh. So that has to be 5. Ooh, that messes with our summation. 50, that gets us 20, I think. 20, I believe. 5, 11, 20. And there's a total of 50 days. So 11 days where she wore neither a tie nor received a compliment. 30 days where she received a compliment. Oh, that has that number. 25 right here. 30, that's 9. I think that's right. 30, 20, yeah. 11 days where she did not, that's 30, where she received a compliment. 16 days where she did not wear a tie, and there are 50 days in total. 25 plus 5 plus 5 plus 11 plus 9. 50. Yay. What line fits a graph below? So, none. So it's nonlinear association. It seems to be a parabolic. All those are linear. Yay. Yay. Goodbye.